Okay, so today what we're going to talk about is we're going to talk about lesson 6-2. And so what I'm going to do is, yes, in fact, I did do a nice, oh, wait, I'm going to hand those out later. I did, in fact, do a nice little note thing for you like I did yesterday, and we're going to go through that. The very first thing, what we're going to do is we've got to do an activity on vocab. Okay, thanks. And so now, notice what it says here. It says, write a good definition of each bold-faced term. Discuss your definitions with others in your group. Agree on a common set of definitions as a class, and then add them to your definition list. In your notebook, draw and label a figure to illustrate each term. So here you go. This is what you're looking at. Here is a central angle. This is not a central angle. I want you to come up with a definition of a central angle. So pick a sheet of scratch paper. Talk amongst your group. Okay. And do that.
And it's an angle that is made up with. Okay, what? Central angle?
Yeah, what's that?
And what you said was? I said it's an angle that's.
I want to hear the definition of that group right back there. What do you have?
In a central angle, all the angles come from the center point of the circle.
All the angles come from the center point of the circle. Okay, what about you guys?
We had angles made by 2 or more radii.
Okay, angles made by 2 or more radii. So now what we're going to do is we're going to look at the following definition. This is the one I had. Here's a central angle. Central angle. Vertex is at the center of the circle. Okay, the vertex is at the center of the circle. So central angle is an angle whose vertex is at the center. Mainly because, if you notice, the ones that were not, they don't fit that definition. So the vertex is at the center of the circle. So now what we're going to do is we're now going to look at another set of 2, and you're going to do the exact same thing. So I want you to now look at inscribed angles. Come up with the definition. Okay, so definition of inscribed angle, what do you got back there?
Angles inside a circle that do not pass through the center.
Ooh, angles. Okay, that sounds like a good one. What about you guys?
Yeah.
It says all segments are inside the circle, or all angles and segments are inside the circle.
Okay, so let's go ahead and look at what I have. An inscribed angle. The vertex is on the center, and the sides are chords of the circle. And so what's going to happen is, if you notice with those things that I've given you, I'm going to now pass out the same thing that we gave you yesterday, that condensed lesson. And so what I want you to do is look in the Investigation 1 section. It gives you a place to fill in the blanks. And so first of all, if you notice that first blank says a central angle is an angle whose vertex is. What would go in there? What would go in that first blank? It's about 1/3 of the way down that sheet of paper I just gave you. A central angle is an angle whose vertex is the center of the circle, or the center. Okay, now a little bit longer. It says an inscribed angle is an angle whose vertex is
In the center.
is on the circle, and whose sides are chords. So now what we're going to go ahead and do is we're going to go ahead and go on into Investigation 2. And I'm going to ask that you use this sheet of paper that I just gave you. I want you to actually skip to step 2. Use the picture they gave you. I want you to measure angle BOA and COD. Tell me what you get. Measure BOA. And then measure COD. What do you discover about BOA and COD? What do you discover?
Wait.
BOA and COD.
probably the same. I'm having a hard time.
So, just a little tidbit, these are all radii. Ah, they're congruent.
I don't know how to use measuring. I'm a genius.
So those are the exact same measure. Now, just a little tidbit. Before we even measured, let's think about what we have. So look up here on the figure. These are all radii. So what is the one thing you know about all radii?
They're all the same.
They're the same, right? And then they also tell you that the chords were congruent. So basically, I know that these two are congruent. So technically, what do you know about those two triangles?
They're the same.
They're the same by what?
SSS.
Side, 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 good. So if they're the same, then what we know is that this and this are the same. We also know that this angle and this angle are the same. And we know that this angle and this angle are the same. So let's go ahead and complete the conjecture they give us. The chord central angles conjecture states that if two chords in a circle are congruent, then they determine two central angles that are
Equal or congruent.
congruent. So basically, if you have two chords that are congruent, they determine two central angles that are congruent. Okay, so let's complete this one. If two chords in a circle are congruent, then their intercepted arcs are congruent. Okay, intercepted arcs is what we looked at a little bit yesterday. So let's revisit what that means for those of you that are kind of wondering. Okay, what they're saying that is if two chords are congruent. So if this chord is congruent and this chord is congruent, what they're saying is that this measure and this measure are the same. And that should make sense because they go with the central angle here. So those two are the same. Keep that in mind because you'll need that on your homework today. So let's go ahead and look at investigation 3. Investigation 3, if you turn, notice it says to construct a large circle, mark the center, construct two non-parallel congruent chords. Then construct the perpendiculars from the center to each chord, which is what's been done here. Okay, how does the perpendicular from the center of a circle to a chord divide the chord? So basically what they're saying is, what does this segment here do to the chord? Bisects it. So really, what is it? It's the perpendicular bisector. So let's go ahead and look at the following. The perpendicular from the center of a circle to a chord is it's the bisector. They've already said that it's perpendicular, but technically that's what it is. It's the perpendicular bisector. So let's talk about what that means to you. If you know this is a perpendicular segment, you know that this measure and this measure are the same. Let's look at the next one. Two congruent chords in a circle are blank from the center of the circle. Let's see, good call, equidistant, nice job. Two congruent chords in a circle are equidistant from the center of the circle. Okay, let's look at the very last one. A lot of stuff today. So let's look at investigation 4. Construct a large circle, mark the center. Construct two non-parallel chords that are not diameters. Then construct the perpendicular bisector of each chord and extend the bisectors until they intersect. And so basically what's going to happen is I'm going to construct a perpendicular. So I'm going to construct something that goes like this. And I'm going to construct something that goes like this. Oh. The perpendicular bisector of a chord passes through the center of the circle. So basically, if you had a ton of chords there, they are all going to have their perpendicular bisectors pass through the center. Okay, now your homework today. I'm going to need you to go ahead and turn to page 320 and 321. So I need you to go there right now. 320 and 321, 1 through 12. One through 12 is going to be your assignment. It's going to be finding a lot of measures. Okay, due tomorrow.